At A level, you are not going to be asked to draw electron shell diagrams like you were at GCSE. Instead, you'll just be asked to write the electron configuration. So if I look at the way I have depicted the electrons in magnesium, if you were asked about this, you wouldn't be asked to draw out this whole diagram. You'd just be asked to write the following. So at GCSE, if I was asked to write the electron configuration, I just write 2, 8, 2. At A level, what I would do is I would write 1s and a little subscript 2 to tell me about 2 electrons in the 1s orbital. Then I put a comma. The next orbital is 2s, and I've got 2 electrons. The next orbitals are the 2p orbitals. Now I can just write all of these together. Instead of writing out 2px, 2py, 2pz, I can just write 2p, 1, 2, 3, 4, 5, 6, and write 2p6. Then I move on to the next one, which is 3s, and I write 3s2. And that's how the electron configuration would look for magnesium. If I look at chlorine, I'm going to do exactly the same thing. The first orbital is the 1s orbital, and it's got 2 electrons. Then I've got the 2s orbital, which is 2 electrons. Then I've got the 2p orbitals. I'm not going to write them all out individually, 2px, 2py, 2pz. I'm just going to write 2p, so I'm going to put the 6 electrons all in there together. Next up, I've got the 3s. It's got 2 electrons. And then if I go up to the top, I have got the 3p orbitals. I've got 2 in px, 2 in py, 1 in pz, which gives me 5 electrons in total in my p orbitals. You are going to become incredibly familiar with the order of the orbitals. It might seem a little bit confusing now, but after you've practiced a few of these, the 1s, 2s, 2p, 3s, 3p, it becomes rote, and you will know which orbital comes next and how many electrons you're going to be putting in each one. I'm going to do a slightly harder example now. We're going to have a look at calcium. So you were required to draw calcium at GCSE, so I will use the GCSE model as well. Calcium has 20 electrons, okay? So in your first shell, you had 2 electrons. In your second shell, you used to put in 8. In the third shell, you would also put in 8. 4, 5, 6, 7, 8. And then you moved on to the fourth shell and you put 2 electrons. And this worked out really well at GCSE because you had 4 shells, calcium's in period 4, and you ended up with 2 electrons in the outer shell, calcium's in group 2. If I look at the equivalent at A level, right, this is my energy. As always, my lowest energy orbital is the 1s. That's going to have 2 electrons in it. Then I move into the second shell. In the second shell, I've got a 2s, and I've got 3 2p orbitals, which I'm just going to lump all together as 2p. 2s can hold 2 electrons. I can put 2, 2, and 2. So there's my 8 electrons, just like I had in my second shell. Then I move into my third shell. We've already seen above that we have a 3s orbital, and we have 3 3p orbitals. 1, 2, 3, 4, 5, 6, 7, 8, just like we had at GCSE. But what we haven't talked about at GCSE is the fact that the third shell can actually hold more than 8 electrons. The third shell can actually hold 18 electrons. And the reason it can hold 18 electrons is because as well as the 3s and the 3p orbitals, it also has 3d orbitals. And it has got 5 3d orbitals in total. So 1, 2, 3, 4, 5 3d orbitals. And each of these 3d orbitals can hold 2 electrons, which gives me 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons in total in the third shell. If this is the case, and we can fit 18 electrons into the third shell, then why did we move to the fourth shell before the third shell was full? The reason we moved to the fourth shell is because in the fourth shell, the first orbital you're going to encounter is the 4s orbital. The s is always the first orbital you will encounter each time you move up an energy level. So we're going to come across the 4s orbital. And even though the 4s orbital is in the fourth energy level, the 4s orbital is actually lower in energy than the 3d orbitals. So the 4s orbital would sit around about here. It's higher in energy than the 3p, but it's lower in energy than the 3d. And what happens with calcium when I'm filling in my electrons is that the lowest available energy level will always fill first. So once I've got my 3p energy level full, instead of going to 3d, the electron's actually going to go to 4s because it's lower in energy than the 3d orbitals. That means my remaining 2 electrons from calcium are actually going to jump ahead to the fourth shell before that third shell is full. And the reason they do that is because that 4s orbital is lower in energy than the 3d orbital. And that's why at GCSE we end up with something like this. We weren't skipping to the fourth shell because the third shell was full, although I think we led you to believe that we were. We were skipping to the fourth shell because the 4s orbital was lower in energy than the 3d orbital, and so it fills first. So if I were to write the electron configuration for calcium, I would write it as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. I don't even need to include those 3ds because they haven't been filled. I'm now going to look at bromine because I used this example at the start. As bromine with its 35 electrons, when we try and use the GCSE electron configuration, we were running into all sorts of trouble because we knew we had to fit them all into 4 shells, but following our old rules, we ended up with 17 electrons in the fourth shell, which is more than the 7 it's supposed to have as a group 7 element. So I'm now going to draw out the energy levels at A level, which means, once again, I'm going to start with my 1s orbital. 2 electrons will go in there. After 1s, I get 2s. After 2s, I'm going to get 2p, and I've got 3 of them. They will all fill up. After 2p, I have got 3s. After 3s, I have got 3p, and there are 3 of them. And we said that after 3p, we had 5 3d orbitals. 1, 2, 3, 4, 5. They are my 3d orbitals. But then I had a 4s orbital, which was lower in energy than my 3d. So at the moment, I've assigned 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons. I've got another 17 electrons to go. And what's going to happen is, of those 17 electrons, because you're always filling the lowest energy level first, 2 of those electrons are going to go here into the 4s orbital. Once those 2 electrons have been placed in the 4s orbital and the 4s orbital is full, then the electrons will start to fill into the 3d orbital. So I've assigned 12, how many have I assigned? I don't know, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I've assigned 20. I'm now going to start filling them into our 3d orbitals. And my 3d orbitals can hold 2 electrons each, which means I've assigned another 10 into my 3d orbital. That means I need another orbital. After 4s, okay, after s always comes p. So here is 2s, 2p, here 3s, 3p, here it's going to be 4s and then 4p. And 4p will be higher in energy than 3d. Remember, with 4p, you've always got 3 of them. And I have got 5 electrons left to assign. So I've assigned 30 electrons so far. I've got 5 electrons left to assign. 1, 2, 3, 4, 5. That's all of bromine's electrons now assigned. It's in period 4, so in total, there should be 4 different energy levels. I've got electrons in the 1s, I've got electrons in the 2s, the second energy level, I've got electrons in the third energy level across S, P, and D, and I've got electrons in the fourth energy level. So I have got 4 different energy levels for bromine. In the outer shell, and the outer shell is going to count as the fourth energy level, I've got 1, 2, 3, 4, 5, 6, 7 electrons in my fourth energy level, which is consistent with the fact that bromine is in group 7. So you're going 3s, 3p, 4s, then you go back and fill the 3d, and then you're going to go from 3d up to 4p. And if I were to write this out as an electron configuration, I would write 1s2, 2s2, 2p6, 3s2, 3p6. When I'm writing this, although the 4s fills first, when I write the electron configuration, you typically do write the 3d first, and then you keep the p's together. Now, when I filled it, I filled 4s and then went back and filled 3d, but when I'm writing it, I put all of the 3's together and then the 4's together. If you wrote it the other way around, you'd still get the mark, but this is the common convention, that you go 1, the 2's, the 3's, and then the 4's. Okay? What you should notice in terms of a pattern, that it always goes S, P, D. And each time you go up an energy level, you're getting an extra set of orbitals. So on the first energy level, I only had 1 type of orbital. I only had S. When I moved to the second energy level, I now have 2 types of orbital, S and P. When I went to the third energy level, I have 3 types of orbital, S, P, and D. When I go to the fourth energy level, and I haven't got them drawn here, but I would have 4 types of orbital. I would have S, P, D, and F. Okay, you never have to go beyond 4p, because the biggest atom you are asked to draw is krypton, which has just 1 more electron than bromine, and that electron would fit in right here. So you never have to go to a diagram that will be bigger than this. But just know, because it's the 4th energy level, you would have 4 different types of orbital. Out of S, out of P, I would have D, and then I would have F. I am going to do some of the questions that are in the booklet. I'm going to go through some of the answers. So I would advise doing the questions first and then having a look at the answers, which will be in the next video.